Okay, so where we're going to start, we started talking about y equals mx plus b, and y equals mx plus b is our slope-intercept form. So one of the things we really have to do is our main goal is to try and get y by itself. So it doesn't matter so much, just get y by itself. So if we have negative 2x plus y equals 3, the way that we're going to do this, remember how to balance. So it's a minus 2x. So I'm going to add 2x to both sides. And you get y equals 2x plus 3. You don't have to do anything else. The only other thing that I'm asking you to do is to look for m and b. Sorry about that, guys. So let's continue talking about slope. So let me put this in a different color. We have y equals mx plus b. So whatever is in that spot, well, goes here and this goes here. So our m value, which is our slope, is 2. If we're turning this into a fraction, it's going to look like 2 over 1. Now our b value, which is also known as our y-intercept, is just that, it's 3. That's it. That's all we're doing here. That's just what we want to look at. So let's try some more examples. What happens if we have 2y plus 3x equals 4? We still want to get y by itself, but right now I multiplied by 2 and there's that additional 3x. So think back to when we did multi-step equations. I'm going to subtract 3x from both sides. And you end up with 2y equals negative 3x plus 4. Then we're going to divide by 2. And remember, when we divide by 2, you have to do that to everything. So then y equals negative 3 over 2x. And then 4 divided by 2 is 2. So my whole part of this is I want to keep this as a fraction, because when we start graphing this, our slope is going to be rise over run. So our m value here is a negative 3 over 2, and that's perfectly fine. And our constant, or the y-intercept, is going to be 2. We're just going to leave it like that. So what happens if we want to find out if something is a solution? So we're going to say solution, question mark. So if we have y equals 4x minus 2, and we are told that the coordinate pair is 3 and 4. So think back, with our coordinate pairs, this means this is your x and this is your y value. So I'm going to rewrite this where instead of having just the x and y, where I'm going to put in the coordinate pairs. So we have 4 equals 4 times 3 minus 2. So 4 times 3 is 12 minus 2. 4 equals 10. Is this true? No, this is not a solution. If they were equal, it would be a solution, but since they don't equal each other, it can't be a solution. So let's try 2 plus 3y equals 4x. Now let's see what happens when we put in, let's see, we're going to put in a 1 for x, and then what can we put in for y? Let's put in a negative 2 and see what happens. So here we have our x and our y again, and I'm just going to substitute those in. So we still have our 2, and then it's going to be 3 times negative 2 equals 4 times 1. So 2 plus 3 times negative 2 is negative 6. 4 times 1 is 4. So 2 plus negative 6 is negative 4 equals 4. This is also not a solution. We came really close, but because it's a negative, even if they are the same number, they still aren't the same. Okay, so just be careful of those. The other one we want to look at is coordinate pairs. Coordinate pairs. So y equals 2x plus 1. And I want to know what are some coordinate pairs. So I'm going to make a table, an x and y table. And I'm going to come up with 3 different values. They can be anything you want. I want to start with 0, 1, and 2. So if I put in 0, so it's going to be 2 times 0 plus 1. 2 times 0 is 0, plus 1 equals 1. And then 2 times 1 plus 1 equals 2 plus 1, which is 3. And then 2 times 2 plus 1 equals 4 plus 1. So this is going to be 5. So our coordinate pairs in this case would be 0 and 1, 1 and 3, because I put in 1, I get out 3, and then if I put in 2, I get out 5. So this is the whole point of coordinate pairs. So you come up with your own numbers. You are more than welcome to use the 0, 1, and 2. Those work as well, but this is all you're doing for these. Remember, if you have questions, please come in. There's always lunch study.